Welcome back in our video. Now we will have an example, and as well as we will be discussing these steps on how can we solve the general or the particular solution when we have this DE, when we have a first order linear DE that is either linear in Y in this standard form, or a DE that is linear in X using this form. Okay, so I will now present to you the steps on how to compute or how to solve the solution for the given first order linear DE. So the first step is to set the equation into standard form, okay, like what we have shown in this part, either in linear in Y or linear in X. So this is our standard form. Okay, so we need to set the equation into this form, either in linear in Y or linear in X. Okay, and then right after we set our equation into this form, then we can now determine the integrating factor. Like what I am saying, we will also use this integrating factor in order for this given equation in step 1 to make an exact differential equation. Okay, so for the determination of the integrating factor, we have e raised to px dx. So what is, if we have our equation is linear in Y, we will use this e raised to px dx. And where is our px? Here, this part. Okay, so we will get that, and then we will get the integral of that function of x. Then it will be raised to e. Okay, and the same goes if we have the equation that is linear in X, then we will now get this g of y here. Okay, so remember that. And then right after determining the integrating factor, of course, we will multiply it in our equation, in our first equation, this in equation that is in our standard form. Okay, so if we multiply our integrating factor in our equation, it says here that we can have the exact derivatives. We can have the exact derivatives of y multiplied by the integrating factor, and then is equal to the function of x that is multiplied to the q of x of our remaining, this part here, remaining function on the other side of the equation. Okay, then dx. And right after we multiply the integrating factor in getting the exact derivatives here of y multiplied by integrating factor, then we can now integrate both sides, because this part here is integrable and the other side here is already integrable. They are both, this part here is exact derivatives, and this part here is integrable with x. Okay, so we have the integrating factor in terms of x and the function that is in x. Okay, then right after we integrate both sides, then that is now our general solution. And if any, or if there's a initial condition, then we can now find the value of c, or the value of our constant c, and find our particular solution then. Okay, so that's all for these steps, and we will have an example on the next video regarding this kind of situation. Okay, so see you on our next video.